This tutorial gives you an overview of gases and pressure as they result in the molecular collisions. So what is pressure? Gas molecules are constantly in motion. As they move and strike a surface, they push on that surface, and that push creates a force. Gas pressure is the total amount of force, the total amount of pushes exerted by the gas molecules hitting the entire surface of at any one instance. So that pressure is the force per unit area, or the amount of times it gets pushed upon by the molecules per unit area. The pressure will always move from a higher pressure to a lower pressure. The bigger the difference, the stronger the flow will be. A gas will try to push on anything in its path. Think of blowing up a balloon. The more full the balloon gets, the harder it is to blow, and the tighter the balloon gets, and the bigger the balloon gets. So the air molecules are pushing against the balloon wall, making it bigger, pushing it against its path. Now once you stop pushing on it, stop blowing into the balloon and let it go, the balloon deflates. The more air that's in there, the faster it's going to deflate. The difference in air pressure, for instance, result in weather and wind patterns. The higher the altitude, the lower the pressure. At the surface, the atmospheric pressure is 14.7 psi, which means pounds per square inch. But if you go up in elevation to 10,000 feet, it's only 10 psi. Now psi is a very American way of saying it because it's in the English units. You may recognize psi from when you inflate your tires. Now what this means is, remember, the force is the pressure per unit area. So the unit area is 1 inch squared, and that force is in pounds. So that's how many times the molecules are pushing off of it. Another example in correlation to that is if you're in an airplane and you go up in elevation, you might feel your ears pop. Well, this is the difference in the pressure across the air membrane right here. As you go up in elevation, notice that there's fewer molecules, there's fewer pressure than there is on the inside, and to try to alleviate that, you feel a popping. So how exactly is air pressure measured? It's measured with a barometer, and this is a mercury barometer. So what happens is you have a pool of mercury down here, and as the pressure pushes down on it, the mercury goes up. This is a vacuum, there's no gas in here, so it can rise however much without compressing any gas up here. Now when they say that it's in millimeters of mercury or inches of mercury, they literally mean millimeters of mercury. They're measuring the height in which that mercury rises. The more the pressure, the more it's going to rise. There are several different units for pressure. There's pascals, but notice it's a really big number, so most of the time they'll use it in kilopascals. Atmospheres, which is the most common unit. Millimeters of mercury, what we just talked about, are the same thing as torrs. And those are, all three of those numbers are exact, meaning it could be 1.00000, You don't have to worry about significant figures there. If you convert the millimeters to inches, you get 29.92, and pounds per square inch is 14.7. All of these things are equal to one another. So that means you can then create conversion factors from them. So 101.325 kilopascals is the same thing as 14.7 pounds per square inch. Or 1 atmosphere is the same thing as 760 torr. You don't have to go through all these units to get from one to the other. You can just pick two of them and relate them to one another. So let's do some practice with the conversions. A high-performance bicycle tire has a pressure of 132 psi. What's the pressure in millimeters of mercury? So as always, 132 psi, we're going to put the number we're trying to convert over 1. If we look back here, we notice that pounds per square inch is PSI, 14.7. It's asking for it in millimeters of mercury, which is 760. So we can relate those two numbers in a conversion factor. So 760 millimeters of mercury is the same thing as 14.7 PSI. So I have PSI on the top, I want to put PSI on the bottom, and that's 14.7, and that's 760 millimeters of mercury. So I times 760 divided by 14.7, it comes out to be 6824 millimeters of mercury. Our number in the question itself only has 3 significant figures, so it comes out to be 6,820 millimeters of mercury. We're going to do one more example. Convert 45.5 psi to kilopascals. Once again, we see that 101.325 is the kilopascals, and then 14.7 is pounds per square inch. So we can make a conversion factor out of that. 14.7 psi is equal to 101.325 kPa. So we put the number we're trying to convert over 1. We have PSIs on the top, so we want to put PSIs on the bottom. And that is equal to 101.325 kPa. So 45.5 times 101.325 divided by 14.7 comes out to be 313.625. 3 significant figures, so 314 kPa. And that is your introduction to pressures.